Okay, good evening everybody. Today I'm talking about Pythagorean theorem, and I'm pretty sure you've seen this before. It's pretty common in 7th grade math. I'm going to show you how I teach it. Maybe it's a little bit different than what you've seen, maybe it's not, but I'm going to ask you to know how the way I like to show it. Okay, if you notice what I have drawn here, I've drawn 3 different triangles and in 2 different colors. Every single time you do a Pythagorean theorem problem, I'm going to want you to draw the pictures, draw the triangles, and I want you to color code them just like I am color coding them. So what you notice here is that this part right here is the same color. It's in blue. On every single triangle, it's the same blue color, no matter which direction the triangle is going. So then the way you know what to color the blue side is the one that has the right angle in it. So the two blue sides that form the right angle, the 2 sides that form the right angle should be blue. So there's my right angle. Those are the 2 sides that form the right angle. The side that is opposite the right angle is in red. So I'm going to ask you to color code these whenever we do these problems. I want the side opposite the right angle to be in red, and I want the 2 sides that make up the right angle to be in blue. It's going to help you keep track of one very tricky thing when we do these. Okay, so now we need some names for this stuff. So the 2 sides that are in blue are called leg 1 and leg 2. It doesn't matter which side is which. If you want to make the long side leg 1, the short side leg 2, that's fine, doesn't matter. They're interchangeable. That's why they're both blues, because they don't matter. So then this is L1 and L2, and we'll say this one is L1 and L2. They don't matter. I could have switched L2 over here down to here if I wanted to. They're interchangeable. What's not interchangeable is the red line. The red line, I'm sure that we all remember from the first time that we studied this, is called the hypotenuse. Okay, it's the hypotenuse. And the hypotenuse is always opposite the right angle. So here's my right angle. It's opposite the right angle. Okay, so on each one of these, this is the hypotenuse. So I'm just going to write HYP and HYP. That's important because when I write my equation, it's a little different than perhaps what you have been seeing. And that is, many of you probably have seen this equation before for a Pythagorean theorem. A squared plus b squared equals c squared. That's fine, it works, no problem. The only reason I don't like a squared plus b squared equals c squared is because a lot of students don't know what a, b, and c represent, and they mess this up. They get the easy ones right, so they think they understand how to do the problem, but as they get more difficult, they start to screw up what is c. So the equation that I like to use instead is this: L1 squared plus L2 squared equals hypotenuse squared. I'll write that a little bit bigger over here. L1 squared plus L2 squared equals hypotenuse squared. And you can probably see why it's a little bit better the way that I'm writing it, because I'm telling you that the first one is L1, the second one is L2, and the answer is the hypotenuse. Where this one up here is very general. It just says A, B, and C, and of course kids can screw that up or mess that around. Okay, let's take a look at some examples here. Okay, so we have some problems set up here. So first thing I'm going to do is I'm going to go ahead and color code. And so just like I want you guys to do, this side is going to be blue, and this side is going to be blue. And they're both blue because they make up the right angle. And then this side, of course, is going to be red. So once I have the color coding, then I'm going to write the formula, which is L1 squared plus L2 squared equals hypotenuse squared. And once I have my formula written, then I can go ahead and plug it in. Oh, let me change that formula real quick. Sorry, I want to color code it a little bit better to remind us. Hypotenuse squared. So my L1 is going to be this one here. Make that x. So that's x squared. My L2 is this one here. So that is plus 12 squared equals my hypotenuse, which is 13 squared. Okay, so now I can go ahead and work the problem out. So x squared is just x squared. 12 squared is 144. And 13 squared is 169. If you don't know 13 squared, that's fine. Just multiply it out, 13 times 13. My next step is to subtract 144 from both sides. So I get x squared is equal to 25. And then my last step, the opposite of squaring a number is square rooting. That's why we were working with square roots the other day. So I got to take the square root of x squared. And if I take the square root of the left side, I have to take the square root of the right side. Anything I do to the left side, I have to do the right side. So the square root of x squared, what that does is it cancels out the x's, or the squares, and I'm left with x. And the square root of 25 is equal to 5. So that means that x is equal to 5 right here. Okay? So now I'm going to do another one here. I'm going to try and squeeze in, try and write a little bit smaller. So my formula then for this one is L1 squared plus L2 squared is equal to hypotenuse squared. And my L1 for this one is my L1 for this one is 8, so 8 squared. My L2 is 6, and again, if you flip those around, it doesn't really matter. And my hypotenuse is y squared. Notice that every time I plug in, I use parentheses. Please get into that same habit. Now, 8 squared is 64, 6 squared is 36, and y squared is y squared. Next, I'm going to combine like terms here. So 64 plus 36 is 100. It's equal to y squared. And then my last step is square root to get rid of that square root the left side. So I square root both sides. 10 is equal to y. And if you're wondering, yes, you always do square root both sides. You have to get rid of this x squared right here. And the only way to get rid of that x squared is by doing the square root symbol. Okay, moving on to the next problem. And for these, I'm just going to show you how I want you to leave your answer. The process is exactly the same, but I'm going to have you guys leave your answer until we learn how to estimate a little bit better. So the first thing I'm going to do is L1 squared plus L2 squared is equal to hypotenuse squared. I keep doing that in blue. I don't know why I keep doing that in blue. And so my L1 for this one is 8. Again, I use parentheses. My L2 is 10. Using parentheses is equal to x squared. Now I'm going to go ahead and solve it using order of operations. 8 squared is 64. 10 squared is 100 is equal to x squared. Going to add 64 and 100 to get to 164 equals x squared. I'm going to divide both sides, or excuse me, I'm going to square root both sides. Square root of x squared gives me x only. And I don't know the square root of 164. That's not one that we have memorized, so I'm just going to leave it as 164. And this is what I was talking about. This is perfectly okay. If it's a square root number that you don't know already memorized, then you can just leave it with the square root symbol in the answer. And that's a perfectly fine answer. Okay, on to the next one here. And so I'm going to first write down my equation. L1 squared plus L2 squared equals hypotenuse squared, and haha, I remembered to use red. And so my L1 is going to be x. So x squared. Remember, I could have picked 7 for my L1. It doesn't matter. Those two are interchangeable. But what's not interchangeable is the 12. The 12 has to be the hypotenuse. Okay, and so now I'm going to go ahead and solve this. So x squared is x squared. 7 squared is 49. And 12 squared is 144. My next step is to get x by itself, so I'm going to subtract 49 from both sides. On the left-hand side, I have x squared. On the right-hand side, I have 95. And then I take the square root of x squared to get x by itself. Take the square root of the right side because I took the square root of the left side. Square root of x squared gives me x. 95 is not one that I have memorized, therefore I just leave it as the square root of 95, just like that. You do have to have the square root symbol in it. Okay, that's the notes for today. Please make sure I would like